Thanks so much, everyone, for coming. We're really excited. This is a great turnout, especially the Monday after spring break. So shout out to you all. We're really excited for this panel. So I'm Jana. I will be moderating this panel. I'm currently a PhD candidate in sociology here at UC Berkeley. Broadly, my research interests are in economic sociology, as well as science and technology studies. And I broadly research the politics of corporate climate governance. We're really excited, and thanks to the staff at Berkeley Economy and Society Initiative for helping put this event together, as well as the Kavli Center for Ethics, Science, and the Public for co-sponsoring. Here at BESI Tech, our goal is to build an academic community at Berkeley and beyond that examine the social dimensions of technology across multiple arenas, including the digital, climate, as well as life sciences. And so today I'm really excited to moderate this important panel and really learn from our speakers about the politics of biohacking. So we have Laura Schmidt, Nina Begus, and Hank Greeley. We'll hear on their perspectives on biohacking, where we can really get into the politics of the technological and biomedical optimization of human bodies. The infrastructures that enable or constrain such optimization are never neutral. They shape which bodies are constructed as deficient, which interventions count as health, and whose enhancement is socially, economically, and politically valued. Bringing together perspectives from the political economy of food systems, the legal frameworks governing emerging biomedical technologies, and bioethics in humanities and fiction, this panel will illuminate how these interlocking systems shape the techno and political possibilities of shaping human bodies. So first, I wanted to introduce our panelists. They'll each give a brief presentation and then I'll ask a few questions, and then I really want to open it up to your questions from the audience. So first we have Laura Schmidt. She is a public health sociologist who investigates the root causes of chronic disease in commercial products, including ultra-processed foods, alcohol, tobacco, and cannabis. Her research has uncovered close ties between the tobacco and ultra-processed food industries, helping us to rethink food from an addiction standpoint. She leads the UCSF Food Policy Lab, which is funded by the US NIH, the National Science Foundation, and the Department of Agriculture to innovate new ways to prevent chronic disease by changing food environments. She also got her PhD from Berkeley Sociology, so shout out to that. It's possible to graduate. Nina is a researcher at UC Berkeley's Center for Science, Technology, Medicine, and Society, and the Berkeley Institute for Data Science. She leads the Artificial Humanities Research Group and funded projects on AI, narration, and culture. Her book, Artificial Humanities, A Fictional Perspective on Language and AI, I'm going to show them your book, published last year, explores how literature, history, and art can deepen our understanding of artificial intelligence and its development. She is the editor of the forthcoming volume, First Encounters with AI, Writers on Writing, featuring essays by professional writers. Her recent papers focus on synthetic imaginary and narratology and language and latent spaces. She also serves on the Public Interest Corpus and MLA task forces on AI and collaborates with the tech industry on educational and policy approaches to AI. Finally, we have Hank Greeley. He is the Dean F. and Kate Edelman Johnson Professor of Law and Professor by courtesy of Genetics, as well as the Director of the Center for Law and Biosciences at Stanford University. He specializes in the ethical, legal, and social issues arising from the biosciences, particularly genetics, neuroscience, stem cell research, and assisted reproduction. He is the author of The End of Sex and the Future of Reproduction and CRISPR People, The Science and Ethics of Editing Humans. Greeley graduated from Stanford in 1974 and Yale Law School in 1977. He clerked for Judge John Minor Wisdom of the Fifth Circuit Court of Appeals and Justice Potter Stewart, then served in the Departments of Defense and Energy in the Carter administration. He litigated at the Los Angeles firm of Tuttle and Taylor before joining the Stanford faculty in 1985. So we have a really great diversity of perspectives here, and I wanted to open it up to our panelists now. So Laura, the floor is yours.
So Jana asked me to share some thoughts about biooptimization from the standpoint of the political economy of food. Who wins, who loses, and who profits? I'll get into the profit part quite a bit. So I've been studying the food industry at the UCSF Center to End Corporate Harm, where we have a research program that focuses on health-harming industries as 21st century vectors for chronic disease. Overall, chronic diseases account for 74% of deaths worldwide, and just 5 commercial products account for 31% of global deaths: fossil fuels, tobacco, chemicals, alcohol, and ultra-processed foods. So my empirical research, like a lot of my colleagues at the Center to End Corporate Harm, focuses on the UCSF Industry Documents Library, which is the world's largest collection of internal documents on health-harming industries. This is an online archive. It's got over 30 million documents in it. It's available to anyone who wants to use it. It's a great source for researchers. A lot of the materials came to us through public litigation, whistleblowers, Freedom of Information Act requests, and it really allows researchers to peer inside corporations and see what's going on behind the veil. So my work focuses on the commercial development of ultra-processed foods since the 1960s, when a significant part of this industry was owned by the tobacco industry. And the ultra-processed food industry today is basically controlled by 8 multinational corporations. Nestle is the largest, based in Switzerland. Then Coca-Cola, Mondelez, Conagra, Kellogg, Mars, PepsiCo, and Kraft Heinz. Notably, all of these firms are now marketing products that focus on biooptimization. So it's very relevant to this topic today. I don't do research on biohacking per se, but I do see the impact of this on the food industry, and I think it's quite important. At the broadest level, the food industry is leveraging biooptimization to create new product lines to reach new markets worldwide. Biooptimization is also shifting the health marketing messaging off of the promotion of weight loss products and onto a health promotion message. And I would argue that by churning out a steady stream of cheap consumer products that promise to prevent chronic disease and increase longevity, the food industry is mainstreaming the ideology of biooptimization. By the ideology of biooptimization, what I mean there is the belief that to extend lifespan and delay the onset of age-related functional decline, individuals should follow a disciplined set of lifestyle protocols that are highly personalized based on extensive testing of their personal genetics, their metabolome, and blood biomarkers. This is a radically personalized view of health that defines aging and age-related chronic diseases as a matter of personal responsibility. Of course, this view flies in the face of everything we know about the fundamental causes of mortality and chronic disease, which are environmentally determined. Health, and especially chronic disease, are quite literally defined by your zip code. Your zip code does a pretty good job of capturing the effects of economic and social inequality on health, as well as exposures to unhealthy commodities and the marketing of those exposures, and contaminants in the air, water, and food. The food industry's products for biooptimization are manifesting in a wide variety of new, quote, functional food products. Functional foods may be eggs enhanced with omega-3 fatty acids, high protein and high fiber beverages and snack bars, fermented foods bolstered with probiotics, and foods augmented with herbs and medicinal mushrooms. So these functional foods are typically mass-produced using ultra-processed food technologies and are marketed as effective in extending lifespan and preventing disease. The, quote, functional additives range from micronutrients to herbs to bioengineered and genetically modified ingredients. But the mainstay is extremely low-cost food processing byproducts. These that are just, normally these would have gotten thrown out. So these are things like the whey from processing milk, which is used as a protein supplement, and grain husks for fiber. The industry is rapidly scaling up functional foods. Food science firms that service these food companies, for example, are using AI to discover new functional ingredients for use as food additives. Functional foods are not to be confused with fortified foods, which have been around since the birth of our industrial food system in the early 20th century. Fortified foods are designed to prevent nutrient deficiency diseases like scurvy and rickets that occur from refining ingredients before industrial production. Functional foods are something entirely different. They're being marketed with subtle claims for improving health and longevity, to get around FDA marketing restrictions on making overt health claims about food ingredients. They don't directly claim that they can cure diseases. Instead, they focus on the, quote, functional benefits of the food, that it supports immune health, or that it promotes healthy digestion, or a healthy gut, or it helps maintain joint mobility. For effective marketing, they depend on social media and paid online influencers who familiarize the public with the new concepts emerging out of medical research over at UCSF where I live, such as gut dysbiosis, glucose regulation, improving energy and mental clarity, boosting immunity, hormone regulation. Today, these, quote, modified functional foods are a $330 billion global market, and they are proliferating new product lines as we speak. So I want to make three observations about functional foods that we might make for an interesting discussion as we move along and talk more about biohacking. So the first is that functional food products tend to emerge in markets that are adjacent to high-end biohacking devices and drugs that are only available to elites. By those elite therapies that are quite niche and very expensive, I'm referring to continuous glucose monitors, red light beds, ozone therapy, therapeutic plasma exchange, and pharmaceutical peptides like testosterone and GLP-1, the agonist, the hormone implicated in drugs like Ozempic. So in this sense, functional foods are kind of like a poor man's alternative to elite biohacking tools. Functional foods are cheap, they're packaged consumer goods marketed to do the same things as expensive biohacking drugs and devices. So for example, in lieu of a continuous glucose monitor, I can optimize my glucose regulation by drinking sodas fortified with fiber. In lieu of going to an expensive clinic for infusions of experimental peptides for, say, low testosterone, I can drink sodas fortified with the herb ashwagandha. As the industry rapidly scales up with functional foods, it's mainstreaming biooptimization for the general public. A related observation is that these functional foods are increasingly blurring the lines between food and the pharmaceutical industries. The advent of GLP-1 receptor agonist drugs like Ozempic has been a real game changer for the food industry. I follow these trade publications very closely, and what happened initially, sort of circa 2022, was when these drugs came onto the market, was that companies saw this as a real threat, and they began doing consumer research only to find that the consumers on GLP-1 drugs, now 12% of the US population, were not consuming their flagship products, soda, chips, ultra-processed junk foods. But within a year, the companies quickly pivoted to marketing GLP-1 friendly foods, functional foods in smaller packages fortified with fiber and protein, targeting the GLP market and the side effects that people experience, such as sarcopenia or muscle wasting. More recently, companies like Nestle have rolled out whole functional food platforms that claim to raise endogenous GLP-1 produced in the gut naturally through protein drinks and fortified candies. The food industry forecasts GLP-1 users are going to make up about 30% of the food and beverage sales by 2030, which explains why designing for this market is such a focus for them. And they're viewing GLP-1s as a long-term structural change in their market, not just a cyclical development. So here we're seeing real blurring of the boundaries between pharmaceuticals and food. Second point. The food industry was already really well positioned to leverage biooptimization when it came along because of its history of marketing better-for-you foods. Better-for-you products substitute, we're all very familiar with these products. They substitute artificial sugars and fake fat for the real thing, and they're marketed for weight loss. For decades, this kind of product reformulation has really been the main business of these companies. They figure out what's trending in weight loss, and then they reformulate their product to meet the trend, and then they market it very quickly so they can beat their competitor. So the better for you strategy, based in my documents research, really emerged as soon as major US companies realized that they were contributing to an obesity epidemic. This is literally the 1970s and 80s. The public health community didn't really acknowledge an obesity epidemic until the early 90s. And the goal of the better for you strategy was to retain market share as customers grew more and more concerned about obesity. Eventually, food companies were launching whole weight loss subsidiaries. So a lot of people don't realize that the food industry owns major portions of the weight loss industry. So Weight Watchers was owned by Heinz, for example. Jenny Craig was owned by Nestle. And these companies have been essential in making money off of both sides of the obesity epidemic, right? So now the better for you strategy involves swapping. So there's a difference between better for you and functional foods. Better for you involves swapping out particular harmful ingredients for less harmful ones. Biooptimization through functional foods involves a different spin. It's marketing products to extend life and prevent disease. But from a production standpoint, biooptimization is simply a new type of product reformulation that these companies have been doing for decades and decades. They're well equipped. It's a minor switch in the R&D going into the product lines. So the pivot came really, really easily for these companies. I would add that biooptimization's focus on health as an individual responsibility also has a very, very long legacy in the food industry. Food industry marketing has long focused on the individual's responsibility for gaining weight and for developing cardiometabolic diseases. It's not the product that's the problem, it's you. But today, when 70% of the US population is overweight or obese, is becoming harder and harder for these companies to make the case. So pivoting to functional foods as a life-saving therapeutic modality gives these companies a new version of their very familiar personal responsibility narrative. So that's my final point about, and this is really about functional foods, but biohacking in general, is that it may become a very significant force for medicalization. Medicalization is the societal tendency to problematize more and more conditions of daily life, defining them as medical problems available for intervention. So the main targets of biooptimization are conditions that are downstream of chronic disease outcomes, the things doctors treat: cancer, heart disease, dementia. But not the actual chronic diseases themselves. Biooptimization and functional foods target the symptoms of chronic disease: brain fog, fatigue, gastrointestinal upset, and the risk factors for chronic disease: obesity, insulin resistance, chronic inflammation, dyslipidemia, gut dysbiosis, metabolic syndrome in general. Now, these are conditions that might lead to a chronic disease, but haven't yet. Of course, these intermediate symptoms and risk factors apply to a much larger swath of the population than the people who actually have a chronic disease. It's pretty much everybody. And this has led to a push for medicalizing conditions like obesity. So right now in the journal Lancet, which is one of the leading international medical journals, there's a whole debate going on about the phenomenon called, quote, clinical obesity. The idea that obesity, especially when it's accompanied by something like high blood pressure, ought to be a diagnosis and we ought to medicalize it. The rationale basically comes out of the idea of biooptimization, the idea that we need to intervene on obesity as a medical condition before it actually causes a chronic disease. So biooptimization seems to be elevating a whole new disease nomenclature. We all now know about gut dysbiosis and insulin sensitivity. And it's attacking a much larger range of medical conditions that previously really weren't considered medical disorders. And the target population for these interventions is everybody. And at least everybody who's going to live long enough to possibly develop a chronic disease. So this may be a recipe. What I see here is a recipe for the endless creation of new markets and the expansion of medical interventions as consumer products that insert themselves into many, many aspects of our daily lives.
Thank you, Jana and Marion, for having us here, and thank you all for coming. The last few years, as you've probably seen, I've been mostly talking about AI. So I've been excited to give a talk that's more focused on the biological side of technologies, which have actually always been a part of my work as well. It's just that AI storm has taken over it. Because my work really sits at this intersection of fiction, humanities, and emerging technologies, an approach that I call artificial humanities, which is really this interdisciplinary framework that brings humanistic methods into the conceptualization of technology, into its development and governance. And the approach was initially born out of frustration that humanities are left behind the tech development, even though its central questions are deeply humanistic, historically contingent, ethical, and more broadly philosophical, and even literary. So just to make a little case why even literary, by focusing on language, we can see that the way we think is the way we build, because concepts precede our making. And by focusing on fiction, we can see that the way we imagine is the way we design. This imaginary landscape informs the possibilities of our creation. And fiction doesn't just serve as this cautionary tale, which is how it's commonly presented in science and technology ethics discourse. Actually, at UW, they use a lot of fiction when they teach their med students. But here in artificial humanities, for me, really, the fiction is a research tool that serves as this placeholder for the ideas, that serves as an exploratory practice, and even prompt that helps us assess these uncharted territories of culture in machines or in technologies. So today, as we're looking at these infrastructures that enable or constrain optimization, my goal is to talk about thought infrastructures that we've created. I'll be focusing mostly on imaginaries and on ontologies that have been in place for centuries, really, and are now being challenged with the cutting-edge technologies that don't conform to them. So the questions in bioethics and in AI development are generally quite similar because they pertain to human optimization, to improvement, to this wishing that technology can fix our problems. That's how they always talk about it, right, in Silicon Valley, to this idea of creators' hubris and its social repercussions. And if you look at how currently most AI and humanities convenings deal with the challenges, they are looking at this aligning of values with machines by focusing on human flourishing, and as a result, fostering a greater appreciation for embodied biological entities, including animals. We have always been cyborgs, said many post-human scholars, especially in my field, because we have always tinkered with technologies and we reshaped ourselves through these tools. And artificial humanities encompasses both computational and biological technologies because they are inevitably intertwined and because of the mere idea of artificiality. This term artificial, ars, right, for art, craft, skill, and facere, for to make, it has historically denoted the domain of human making, technique, creativity, and was not in the opposition with the human or nature. It was modernity, really, that introduced the artificial and natural as opposites. So even the term nature didn't label what we consider nature today, and neither did technology. The ancient Greek for word, so techne in ancient Greek, this was the very art or skill by which the artifice was made, but it was not exempt from nature. Human activity was already a part of nature. Nothing that humans did could be unnatural until modernity. It's kind of wild for us not to be Descartian in that sense, because Descartes really in the 17th century excluded humans from nature, saying, yes, we have the same kind of bodies as animals, but he excluded us, saying we have reason, and that kind of puts us above nature in his view. And then in the 18th and 19th century, you have this formation of technology as this concept that's often impure and exploitative of nature. If you just think of Baudelaire, who took the other side, who praised the impure, the artificial, he praised the urbanity and the smokestacks and such in his poetry. So my point is really, we create these concepts and we change them, and sometimes we discard them when they don't serve us well. And human nature technology are some of these basic concepts that have gone through great changes. But in order for us to make an ethical stance, they need to be clear to us. What is technology, for example? I love to do this exercise with my students, right? If you think about CRISPR that you work on, it's really a natural technology, right? It's what bacteria invented to defend themselves from viruses, but then we discovered it and adapted it to our needs. And biotechnology is now merging with information technologies. So information technologies, you could argue, started with accounting and the invention of writing, and through printing press, telephone, all the way to punched cards, which led to computing, the internet, and so on. As an example of this merge, think of a proposed solution to the digital data storage crisis. We know that the amount of digital data in the next 150 years will actually surpass the amount of DNA on the planet. So we're dealing with a large scale problem. So we need to find the whole solution always is we're going to engineer our way out of our problems. So there was a proposed solution to basically store our digital data in abiotic DNA instead of silicon, right? Instead of mineral, instead of rocks. And this technology works actually. It's just not very scalable. It's still costly, which is why we're not using it. Like so many other biotech inventions, it's hard to scale because planetary scales of biology and biotechnology are much different. And so relatedly, this general discomfort that we have around biotechnologies, particularly when interacting with our bodies or with our minds, comes from this natural artificial opposition. I work with this next generation pharmaceutical company, it's called Anthea from Stanford, that presents itself as this solution to an extraction of nature problem. They say we are ending drug shortages with advanced biosynthesis because they manufacture a necessary drug ingredient in a lab. So with yeast, they grow it instead of harvesting a whole field of flowers where they would extract the ingredient from the flowers there. So basically, they say we're transforming this pharmaceutical supply chain and thus reducing the environmental costs as well. But let's think about all these implicit assumptions that you also brought out, right? Diet is natural, or is it? Sport training is natural, right? We let our athletes do the training, but we don't let them take the doping. But is it still natural if they're training at high altitudes? Pharmaceuticals are not natural, but then herbs are natural, right? Or where do we draw the line? So this often translates then into the optimization versus enhancement discourse, which inevitably comes with moral judgment. You either see body as insufficient, as failing, and especially now we see datafication that as a solution because it gives us a sense of control. We can track data, we can supplement it, we can restrict. So hacking the body the way one hacks software, really. And in medical technologies in particular, I like to use Urban Wiesling differentiation about technology either bringing back health to the optimum, he calls it restitution ad integrum, or enhancing it. So he calls it transformation ad optimum. So to put this into a form of question, are we working towards an authentic identity, or are we adding a newly added power, really? When it's a technology, it tends to look like the latter until we legitimize it. And then many people don't consider it as technology anymore. Like think about vaccinations or just like pen and paper. But the line of what is legitimate is moving faster than ethics can follow. And so I actually came during my grad school, I went to the University of Washington's Bioethics and Humanities department, which is under their med school, where they've been dealing with bioethics and medical ethics for decades. And I came there to kind of in search of a solution. What do we do with this, right? What's happening in the AI spectrum, in the biotech spectrum? How can we address this in real time? And I think the problem is prior to the digital sphere, technologies, and especially medical technologies, had this process of establishing a social contract for their applications, for their use. And with the digital, there is no time for the contract because as you've seen, a private company launches a product and in 5 days, as with ChatGPT, right, it was a half-baked product, gets 1 million of users. So consider also this real-time accent-changing technology famously launched by 3 Stanford international students at the company called Sanas. Are they really solving a problem with it? The problem being people being misunderstood over the phone due to an accent? Or are they constructing a new form of language enhancement that results, as many critics have said, in whitewashing and homogenizing culture? Accent reduction can quickly become an expectation, right? Think of elocution lessons. That's not a new thing. The elocution lessons still are a result of social and economic coercion, right? Not having an accent will open more doors for you. Especially when you think about who defines the improvement, who controls this infrastructure that defines the improvement. So I think when it comes to ethics, what we've seen so far is we saw putting ethics as a band-aid to a finished product, and that does very little. My solution really that I propose here, mostly for AI, is to embed ethics into the very creation of the product, with humanists being right there from the very beginning. And we've kind of tried to do that when I was in this consulting practice. But with consulting, it's hard because you just come in and then you leave and you don't really know what you succeeded. So a concrete example of a sort of bioethics problem that I think goes more into what you're going to talk about is what I call the identity problem in prenatal testing and in reproductive selection. Because once you know an embryo's genetic markers, you stop relating to it as this blank slate, and you start seeing it as a person with a future you can evaluate. that shift from anonymous embryo to an identified individual changes the moral calculus, and no amount of beneficence or beneficence reasoning fully really resolves it, because the line between disease or predisposition and the line between preference and enhancement is not biological at all. It's cultural, it's historical, and it moves over time. And in this framing, you quickly slide from health, say disease markers, into preference, height, or whatever might be a cultural preference. And with preference, then you go into legitimacy and into social pressures. And so fiction, such as Gattaca, Brave New World, Octavia Butler's wonderful opus, serves really as an evidence of this. It shows that these dilemmas were thinkable before the actual technology existed. You don't even need to address the actual technology in fiction, which means that technology didn't create the ethics problem from scratch. It just forced the question. And just to conclude, so every concept that I've mentioned today, technology, health, enhancement, has already changed beyond recognition, at least once. And we are in one of those moments again now. The technologies are moving, but so are the concepts, maybe more quietly. And the most dangerous decisions we will make about human flourishing in the next decades won't be made in labs. They'll be made in language, in what we agree to call normal, natural, legitimate. Thank you.
So I want to talk about three things today. First, I want to talk about what the hell is biohacking. Definitions are useful. Second, I want to talk about legal implications. And third, I want to talk in a very broad sense about the ethical issues that some definitions, at least, of biohacking may raise. So what is biohacking? I don't know. I remember when I first saw the term about 20 years ago, it was actually kind of a community hobby. People who wanted to practice biotechnology without having to be in a big company or be in a university or be in a research lab wanted to have their own little labs. And ultimately, starting, of course, in the Bay Area, because everything does, they came up with sort of community labs that people could use. And they called themselves biohackers. The idea was playing off the idea of software hackers and computer hackers. And it was about having fun. It was about learning, educating themselves, and having fun. That use of the term seems to have dissipated, as I think the phenomenon, it's not gone away entirely, but I haven't heard much about those labs, community labs, in a long time. And it sort of moved into changing living organisms with a particular focus on changing human organisms. So now when you say biohacking, you think about people trying to make biological changes to themselves. I do think there's a really interesting and deep set of issues around our changing non-human animals as well as human animals, but we're talking about humans. I'm going to talk about humans today. So right now we seem to think about biohacking as making changes to people that are biological changes to people. Sometimes people think about that only in terms of biohacking being making, quote, improvements, close quote, or, quote, enhancements, close quote. But there are people who are doing biohacking to try to treat diseases that they or their loved ones have, where they think that the biopharma industry, the regulators, and so on are too slow. So even if you think about it as changing people, there's a very murky set of concepts behind this term biohacking. For today's purposes, I want to focus on the idea of biohacking as changing biological characteristics of humans. So what's the law there? Well, being a good lawyer, I will tell you what the two words I tell all of my students that should be the first words to any answer to any question: it depends. Because it always depends. Some forms of biohacking are clearly governed by federal regulation under the Food and Drug Administration. Some forms of things that people call biohacking are maybe sort of kind of a little bit covered by the FDA. Some forms are covered by the FDA, but not enforced by anyone. And some are not even plausibly covered by FDA. So FDA covers products. It covers drugs, it covers biological products, and it covers devices. It also covers cosmetics and food additives and color additives, and it has some food regulation, but not. Yeah, it doesn't have very much. So I'm going to focus on drugs, biologics, and devices. What's a drug? Well, in 1938, Congress said a drug is a long list of nouns that's used to, long list of verbs, treat, diagnose, cure, affect any disease or condition of man or any other animal. 1938, I think they were classing women under the group of man and not any other animal, but it's a long time ago, who knows? So those are drugs. Well, what does that mean? Anything that is supposed to affect, prevent, etc., a condition. Water prevents me from dying of dehydration. Does that make it a drug? Well, it could under that very broad definition. Biologics, that definition came in 1944 in the Public Health Service Amendments Act of 1944, and it is truly bizarre. But the best way to understand it is a biologic is a drug that's made by a living organism. The regulation actually goes back all the way to 1902 when people made toxins and antitoxins by injecting usually into worn out, beaten up old horses, various nasty things, and then taking sera and anti-sera or antitoxins from their blood to treat things like diphtheria or a variety of other really nasty stuff. So something that is made by a biological organism is treated as a biological product. However, FDA says, well, as long as it's being used to treat a condition or treat, prevent, et cetera, it's also a drug. So in FDA's view, all biological products could also be regulated as drugs, but they got two different divisions dealing with them with some interspersing. So for example, most vaccines are made in living organisms, and not all of them. Flu vaccine is made in eggs. So that's a biologic. Blood products are made from blood, which is usually human blood, so that's a biologic. Monoclonal antibodies, the hottest, quote, drugs, close quote, in the world in terms of revenues and profits, those are made by cells. Those are also drugs, but they're biological products. Does that make any difference to anybody other than a law professor whose next quarter's class on FDA law starts tomorrow? Maybe not. You filed a new drug application to get a drug approved with CDER, the Center for Drug Evaluation and Research. You filed a biological license application with CBER, the Center for Biologics Evaluation and Research, to get a biologic product approved. But there's not much difference. Either way, you've got to prove to FDA's satisfaction that this thing is safe and effective for a particular stated use. Then you get devices. Another long list of nouns, articles, things, thingies, items, blah, 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 that treat, et cetera, prevent, et cetera, conditions, diseases. But also, and I forgot this in the drug definition, it's really important. Also, you're a device or a drug if you affect the structure or function of man or any other animal. So what does that mean? I think it means under the statute, and that goes back to 1938, my shoes are a medical device, are a device. They affect the structure and function of my feet. They make it possible for me to walk over sharp, hot, or cold things that I otherwise couldn't do. They keep my feet from expanding to infinite width. They do all sorts of things. This is a medical device because it's something that keeps me warm. All the things, so these definitions are extremely broad. Medical devices are more tricky, but if it's a dangerous medical device, like anything that's implanted in your body, or things like CAT scanners or MRI machines, you have to prove that it's safe and effective before FDA will allow you to sell it, unless it's very similar to something that's already on the market, in which case there's an off-ramp that you can take easily. So those are the things that are regulated. Well, let's talk about that in the context of biohacking. If your biohack is to try to to inject yourself with a gene that will enhance human growth hormone to make yourself taller, that's a biologic product and a drug. Its purpose is to change the structure or function, structure in this case, but maybe function, of the body of man or any other animal. Maybe also if you define very short stature as a disease, to treat or prevent that disease, that's a drug or a biologic. It has to be approved in advance. What if instead you do something that just sounds terrible? You desperately want to be taller in the worst possible way. So you choose the worst possible way. Surgery that cuts your leg bones, cuts in the middle of your leg bones, and then keeps them separated by a centimeter or so. So bone grows back between them. And it does it, you do that several times, and suddenly you're 2 or 3 inches, well, not suddenly. After several years and much pain, you are 2 or 3 inches taller. Does the same thing, affects the structure or function of the body of man. No FDA regulation. It's not a product. It's a procedure. It's a surgery. If you want to do something to keep your hair from disappearing and you rub a cream on it, that's a drug. If instead you have hair transplanted from one part of your body to another, that's not a drug, and that's regulated. So these issues of what FDA does and doesn't do are complicated, but the crucial thing is, if it's clearly covered by FDA, you cannot legally sell it in the US unless it's been approved. Now, there is no international uniform standard thing, so often you can go to some other country and get it done, but you can't get it done legally in the US. Then there are the in-between things. Nutritional supplements, all of which are mainly crap. Not literally, although some probably are in part crap, rodent droppings, but your field, sorry. But FDA regulates them in that you got to tell FDA you're making a nutritional supplement, and you're not allowed to say it treats a disease. And so I remember these wonderful garlic is good for you radio ads. All the goodness of garlic without the taste. I love garlic. I'm thinking, what are they talking about? These people are crazy. Taste is the best thing about garlic. And it improves your cardiovascular health. It improves your memory systems. It improves your immune systems. But it doesn't say it treats Alzheimer's. It treats cardiovascular disease. It treats immune deficiency. It says it does good things for your system. And you also have to say it's not been FDA approved. And then you can sell basically anything. $250 billion a year are spent, 248.6 billion of which are, in my view, wasted in the United States every year on nutritional supplements. Even the ones that you might think are good, like vitamins. If you have a relatively healthy diet, you don't need vitamin supplementation unless you've got some unusual disease. So that's sort of FDA regulated, but not. And then you get to the things that are for general wellness. And FDA has, pushed by Congress, has sort of exempted a bunch of wellness-related stuff. So you've got these things that are kind of being treated like drugs, being sold and huge profits being made off of them. They don't do any good for the most part, and they're not FDA regulated. Then you've got the stuff that isn't FDA regulated at all, like surgeries or other procedures. And then you've got the stuff that is FDA regulated, but it isn't enforced. There are over 500 stem cell clinics in the United States. Almost every single one of them is breaking federal law with the stuff they sell. There are almost no federally approved stem cell treatments, and stem cell treatments almost always will be viewed as drugs or biological products and require FDA approval. Every once in a while, the FDA sends a nastygram, a nasty letter saying it's come to our attention that you are doing this thing. And the company says, well, yeah, we're sorry, and then keeps on selling it. These things are common. Things like the whole peptide stuff that RFK Jr. is wacko about. He's wacko about many things in many different ways, but that's one of them. Not FDA approved, not shown to be safe and effective. Almost certainly, the only thing that it reliably does is make a lot of money for people. Now, personally, I think Dante was wrong. I think there should have been 10 circles of hell. And the bottom circle of hell shouldn't be for traitors, but should be for quacks, at least conscious quacks, people who take advantage of people's desperation to sell them stuff they don't need, that might hurt them, and that the seller knows isn't going to work. And there are a lot of people like that. There are also, I think, a fair number of sincere quasi-quacks who actually believe the shit they're selling and what they're saying, but there aren't that many. So that's the law. And of course, that's the US law. What's the law in Mexico? Different. What's the law in Prospera, on the island of something or another, I can't remember the name now, off the coast of Honduras? The answer is not very clear at all. So to pick up on what was said earlier about rich people, you know, if you can't get it in the US and you got the money for plane fare and the money to pay through the nose for something, you go someplace else and get it done. I think for me, kind of the saving grace about that, Laura, is that it almost never works. And these rich people are paying through the nose for stuff that's more likely to hurt them than to help them. So, law. Last, ethics, understood broadly. 2 levels, broadly and individually. Broad level. Is enhancement a good thing or a bad thing? Is natural a good thing or a bad thing? Our culture tells us one thing, parts of our culture. And of course, anytime anybody says our culture, you've got to interrogate closely what they mean by our, because the US is filled with lots of different cultures and subcultures. But is enhancement a bad thing? Well, if it's unnatural, many people think it is. I'm actually not of that camp, but I think this is something reasonable people can disagree on. I think I'm right, but of course I always do. I think enhancement is maybe the most human thing humans do. Everything we've done since we came out of trees is aimed at making our lives easier. Easier, safer, more convenient. We've enhanced everything about ourselves. This is an enhancement. Clothes are an enhancement. This is not my natural fur. And by the way, these are not blue and yellow for the UC system as much as I respect our state schools. It's for the brave people of Ukraine. But my glasses, part of this is for myopia. Okay, that's a medical condition, short-sightedness. Part of this is for presbyopia, farsightedness, which is a natural thing you get as you get older and your eyes get stiffer. So these are progressives. So if I look in the top, it does one thing. If I look in the bottom, it does another. The nearsightedness, I would say, is a medical intervention. The farsightedness is kind of an enhancement. It returns me to where I was at 30, but I'm 73. I'm not supposed to be where I was at 30. 73-year-olds are supposed to have trouble with, reading close-in things. Is that an enhancement? I am I have to confess, happy user of Ozempic for the last 23 and a half months and 81 pounds. Only minor side effects for me. Is it a health thing? Well, I'm supposed to be healthier. My hemoglobin A1C is much better. My blood pressure's down. Is that why I did it? I did it because my wife kept pushing me to do it. I ran out of good reasons to say no. Is it so many people say, you look so great, you look so much better. Is that an enhancement or is that a health thing? And I sort of think, but I'm the same person, so why are you guys making this big fuss? Is that enhancement? Is that health? I think the right answer to that is going to be the right answer for many of these things. The answer is yes. It's a little bit of both in ways that are hard to tease out. So, is enhancement inherently evil, wrong, non-human, etc.? I don't think so. I think it's what humans do. I think it may be the quintessentially human thing. One thing that interests me, though, and kind of puzzles me, I walk around with a supercomputer in my pocket. It's a lot smarter in some respects than I am. It's an enhancement. It enhances my ability to communicate. It enhances my knowledge. It enhances all sorts of things. It got adopted, pretty much as fast as ChatGPT. And kind of amazingly, this is one of the counterexamples where even in poor countries, a lot of poor people have phones, have mobile phones. We don't worry as much about machine enhancements as we do about biological enhancements. but I don't know why. I mean, my glasses have been with me since 3rd grade. They are much more part of me than my gallbladder. I don't even know whether I have a gallbladder. It's never been taken out. It's never made any trouble. But these are part of me. It might or might not be. So why do we make this distinction between biological interventions, interventions in our bodies, and interventions that our bodies hold? And I swear with these younger generations, I think they keep their phones surgically attached to themselves. Would it matter if the chip for the phone was inside your brain or not, if it's doing the same thing? I don't see it. Last issue here, at the personal level, I think the personal level is the operative level for this. I think competent adult people should be able to screw themselves up just about any way they want to, as long as they don't overly hurt anybody else. I'm a very Millsian liberal in that sense. And I think that if you want to become lizard man, how many of you have seen pictures of lizard man? Nobody? Yeah, look it up. He's changed his face to look like a lizard. If you want to be completely tattooed, which is a sort of lesser way of being lizard man, okay. If you want to grow horns, I don't care. Go ahead, grow horns. If you want to change your various primary and secondary sexual organs, okay, they're your sexual organs. I don't care what you do with them. I might care what you do with them to me or other people, but I don't care what you do. I don't care what you do to your own body, assuming that you're a competent adult. Lots of issues here about what competency means and where you call adulthood and how paternalistic we should be about it. But mine is not the only view. There are people who think that human means something specific, that to be a human means something. Maybe it means to be made in the image of God in many traditions, whatever God's image is. Maybe it means to be normal, to have 2 legs, 2 arms, a nose, a mouth, a brain, all those things. Except we all know people who are humans who don't have 2 legs or 2 arms or a nose, probably not who don't have a mouth, who don't have a functional brain. Unfortunately, many of them are in DC right now. But what does it mean? There are people who have an image of what humanity is. And if they want to hold to that image, that's fine. And there are things that I wouldn't want to change about myself, in part because they've become part of my identity. And I don't want them to be changed, but in part because I just don't want to. And if you want to change yourself, I'm fine with that. If you don't want to change yourself, I'm fine with that. What I'm not fine with is you forcing your views about what a human body should or shouldn't be on other people by making somebody change or not making them change. Just the last bit about this, as I said earlier, anytime somebody says our, you have to worry about who the our is. Anytime somebody says me or I, you have to worry about who the me or I is, because I'll let you in on a secret. I'm not the same person I was yesterday. I'm not the same person I was 24 months ago, except it feels like I'm the same person. I'm connected by a thread of memory. But we are rivers that you never step into the same river twice. And identity is fluid. Our bodies are fluid. Our culture is fluid. We don't like fluid. We like fixed stuff. Biology is all fluid all the way down. Thanks.